Hello, hello. Welcome to another episode of Algebra 1. Today we are doing 5.6 and we are on page 149. 5.6, page 149. We are doing graphing linear equations in two variables. Graphing linear inequalities, in two variables. So a linear inequality in two variables, what is that? Well, two variables. It just means it's going to have an x and a y, and an inequality is greater than, less than, greater than or equal to, less than or equal to. And so it's a linear equality. It's essentially a linear equation, but an equality. So an example would be something like y is greater than or equal to 3x plus 1. We have an inequality, and there's two variables. Now, what's a solution of a linear equality? Well, that could be an x or a y, but the solution is the number set that qualifies for this. So, simply, it's a solution for that. It's a solution for that. And graphing of a linear equality, we're going to end up graphing a linear equality, and what we'll do is I'll show you several of these, and what it's going to end up doing is looking something like this. There's a graph of a linear inequality in a half plane. Well, actually, I just gave you an example of a half plane. Half plane are all points on one side of a line. All points on one side of a line. So I can show you in Desmos. We're going to be using Desmos calculator today, but here's an example of a half plane. It's every point on one side of a line. That's a good example of a half plane. All right. So let's check out these core concepts. So, how do you graph a linear equality in two variables? Well, your first step is you're going to graph the boundary line for the inequality. You're going to use a dashed line for less than or greater than. You're going to use a solid line for less than or equal to, or greater than or equal to. So to graph the boundary line, really all you're doing, not really, but all you're doing, step one, is you're graphing the line. So let's say I have y equals 3x plus 1. I'm sorry, let's say y is greater than 3x plus 1. So I know my y-intercept is 1. My slope is 3 over 1. 1, 2, 3, 1. So this is my line here. So graph the boundary line. This is actually, we're going to do it in a dashed line, and I'll explain more about that later. This is step number 1, graph the boundary line. Step number 2, test a point that is not on the boundary line to determine whether it's a solution or not. So step 2, I'm going to pick a point. So let's say this point right here. Let's say 1, 0. So I have point 1, 0. And I see if it satisfies this. So I have y is greater than 3x plus 1. So 0 is greater than 3 times 1 plus 1. 0 is greater than 3 plus 1. 0 is greater than 4. That is not true. And because it's not true, it means this is not a solution. So what that means is that everything on the other side of the line, of that boundary line, is a solution. So everything over here. So that means that if I were to pick some point out here, let's say negative 5, 2. Negative 5, 2. So because it's in this point that I've just said is a solution set, it should solve this. So, oops, that was step 3, was shading it. Step 3, but I also want to confirm. And then confirm. So I pick this point, negative 5, 2, and let's see if it works for this equation. Y is greater than 3x plus 1. So I have 2 is greater than 3 times negative 5 plus 1. 2 is greater than negative 15 plus 1. 2 is greater than negative 14. And that checks out. So, yes, in fact, I did shade the correct half of this. And that shading is what we consider a half plane. So that is the basics. Now, let's get one last thing in our notes. Make sure you please have this in your notes. If it's greater than or less than, you're going to have a dashed line. Dashed line. Just like that. If it's greater than and equal to or less than and equal to, you're going to have a solid line. That. Take note of that. Make sure you remember that. Use that on all of your pieces. Let me show you actually what that looks like in Desmos. So if I have y is greater than 3x plus 1, I get this dashed line right there. Dash, 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 dash. If I get, I wonder if I could put that in here. How do I put it in here? Where's my calculator? Y is greater than or equal to, oops, that's not where I want it. Y is greater than or equal to, then I get this solid line. So there you see the solid line. If I change that to greater than, it's a dashed line. And that, if you need to put that in the Desmos calculator, come over here to the little keyboard, pop it up, and there's your less than, greater than, less than or equal to, greater than, equal to. Okay. So, let's get into some of our homeworks. Alright, number 1. Tell whether the ordered pair is a solution of the inequality. So we just did that essentially when I checked right here. I was checking to see if this ordered pair, 1, 0, was a solution to this. And I found out that that was not a solution. Then I took this ordered pair and I plugged it in. And I found out that that was a solution. So there we have our solution. So now it gives us a point and a linear equation. And it asks us if it's a solution. So let's plug this in. So I have x is 3 plus y is 2. It's greater than 5. 5 is greater than 5. Is that true? It is not true. No, not a solution. So go ahead and give that one a try, see how you do. Number 3. I have negative 1, 2. Is that a solution to this linear inequality? Let's check. Negative 1 plus 2 times 2 is less than or equal to 4. Negative 1 plus 4 is less than or equal to 4. 3 is less than or equal to 4. Yes. This is a solution. Alright, let's check out number 5. Don't forget to pause the video, do number 2, do number 4, and then check number 5. So I have 3 times negative 1 minus 4 times negative 1 is greater than 6. Negative 3 plus 4 is greater than 6. 1 is greater than 6. Nope. No, not a solution. Alright, go ahead and do number 6. Okay, let's get into some graphing here. So, graph the inequality in its coordinate plane. So, y is less than 4. How do we graph that? Well, if we had y equals 4, you would graph that by saying, here's my y equals 4, y always equals 4. So I have this line. Oops. For inequalities, I need to start out with a dashed line. So here's my y equals 4. But here I have y is less than 4. Well, less than 4 would probably be all of this. So I'm going to shade in all this for my inequality. Y is less than 4. And to check, I'm going to pick a point in here and see if it's correct. So let's just pick this point. So 1, 2. 1, 2. And we'll plug it into here. Well, there is no x value in here, so 2 is less than 4. That's correct. That checks out. Sure enough, that's correct. All right, give number 8 a try. Number 9, x is greater than 3. Well, if I had x equals 3, what it would look like is 1, 2, 3. X is always 3. So I'm going to have a dashed line right there. So I have a dashed line. And then x is greater than 3, so I think it's going to be over here. Let's check and see if I'm right. Why don't we pick this point right here? Let's pick 5, 1. 5, 1. So my x value is 5. 5 is greater than 3 because there's no y value here. 5 is greater than 3. That checks out. So that is my space. All right. Go ahead and do number 8. Try number 10, and then pause the video. Do those two, and then let's do number 11 together. Y is less than negative 2. So there's y is negative 2. And less than, I'm going to say this is probably the less than category because it's less than. And then please check and answer. Let's do 2, negative 3. So let's check 2, negative 3. Well, my y value is negative 3 is less than negative 2. That checks out. Give the video a pause. Give number 12 a try. And get into number 13. Okay, so now we have something different than vertical and horizontal lines. Y is less than 3x plus 1. So my y-intercept is 1. My slope is 3 over 1. 1, 2, 3, 1. So what I'm going to do is I'm going to go 2, 3, 1. If I do negative 3, negative 1, that's the same as positive 3, positive 1, right? That just helps me draw a straight line and be more accurate. Y is less than. Well, before I shade it in, I'm going to check. So why don't we check 2, 2. I think it's going to be this side, but I'm not sure. So 2, 2. So I have 2 is less than 6 plus 1. 2 is less than 7. So that checks out. So I shade in all of this. There you go. We just solved a linear inequality with 2 variables. Nice work, team. X minus y is less than 2. Let's change this into the y equals mx plus b. So I'll go up here and I'll go x minus y is less than 2. Minus x minus x. So negative y is less than negative x plus 2. I'll multiply everything by negative 1. So I get y is greater than x minus 2. Don't forget, if I multiply or divide by a negative, I have to switch my inequality. If I multiply or divide by a negative, I have to switch my inequality. So now can I graph this? Yes. My y-intercept is negative 2. And my slope, what is my slope here? My slope is 1, which equals 1 over 1. 1, 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And it's a dashed line. Okay. Now it says y is greater than this, so I'm going to guess it's up here. So I'm going to plug in 0, 0. I'm going to test 0, 0. 0 minus 0 is less than 2. Nailed it. There it is. Alright, let's do one more and then we'll look at this word problem. X plus 2y is less than 4. So I want to change that into y equals mx plus b. 2y is less than negative x plus 4 divided by 2. So I get y is less than negative 1/2 x plus 2. Because negative x divided by 2 is negative 1/2 x. So go up to 2, then go down 1 over 2. Negative 1, positive 2. Or I can go positive 1, negative 2, positive 1, negative 2. Now this one is a dashed line. That, and its y is less than, so I'm guessing it's down here. So let's go with negative 1, negative 2. So I'm going to plug in negative 1, negative 2. Negative 1 plus 2 times negative 2 is less than 4. Negative 1 minus 4. Negative 1 minus 4 is less than 4. Negative 5 is less than 4. That checks out. So it is, in fact, negative 1, negative 2. So that's on this side. So I shade it in like that. That's how I do an inequality. Just like that. Alright, pause it, finish the other ones, and let's look at number 19. An online store sells digital cameras and cell phones. The store makes a $100 profit on the sale of each digital camera X. So X gets a $100 profit. And a $50 profit on the sale of each cell phone. Y is a $50 profit. The store wants to make a profit of at least $300. At least $300. So greater than or equal to 300 from its sale of digital cameras and cell phones. So we're going to have an X plus a Y. Write and graph an inequality that represents how many digital cameras and cell phones it must sell. Identify and interpret two solutions. So we have 100 times however many digital cameras we sell, plus $50 times how many cell phones we sell, which is greater than or equal to $300. So, can you graph that on this? We're in the hundreds and we're in the ones. Well, here we can simplify. Or maybe when you solve this for y, you'll be back down in the ones. Alright, give that a try. Finish this off. Graph the inequality. Don't forget, it's going to be an inequality, meaning you're going to shade in above or below the line. Okay? Give that a try and have fun with your math. Don't forget to ask me any questions. You can use Desmos Calculator to check your answer, but please do the work in the book. Alright, email me or call with any questions. Thanks.